Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum little kids. This is Shehroz Abdullah. Now today we are going to discuss class 9th lecture number 3, and we are going to discuss graphical analysis of motion, right? Let me recall the previous work. In the previous lecture we have discussed the difference between distance, displacement, we have discussed velocity, we have discussed acceleration, we have discussed different types, mathematical form, and all the things related to that we have done in the previous lecture, right? And now today we are going to discuss what is graphical analysis of motion. Before going to start with graphical analysis of motion, let me discuss one thing. What is graph? You know, graph is a very important aspect of physics in which we discuss the relationship between two quantities, like one quantity is independent quantity, other quantity is dependent quantity. Independent quantity mostly we take on horizontal axis, and dependent quantity we take mostly on vertical axis. Okay. Now graph, for plotting graph, what things are necessary? There are some quantities. For example, variables are required, constants are required, and origin axis and plane is in xy plane we draw different graphs. For example, now we have to draw coordinate axis, x dash, y dash. Okay, the body is moving from point P1 to point 2. We have to find out the vertical coordinates as yi and yf, as well as the horizontal coordinates as xi and xf. Okay, what we do, we draw perpendiculars on horizontal axis like xi and xf, and also perpendicular on vertical axis, so we find vi and vf. Okay, slope is actually a ratio between vertical coordinate to the horizontal coordinate, as that slope is equal to del y by del x. Okay, del y means yf minus yi, and del x mean xf minus xi. Okay, so this is what we call with slope. Okay, now we are coming towards distance time graph. Do remember one thing, distance time graph always gives you speed. Okay, now how we do? Look, the same xy coordinate we have drawn, like this is x-axis, this is y-axis. On horizontal axis we have taken time, okay, which is independent quantity. On vertical axis we have taken distance, which is dependent quantity. Okay, the graph of distance time graph, for example, a body is moving in very straight line like this, and the body having uniform speed. So the graph will be like this, and this is the distance. This is the distance covered on vertical axis, and that will be the distance covered on the horizontal axis. What we represent by time. Actually, in horizontal axis we have time. So 0 seconds, 5 seconds, 10 seconds. On horizontal axis the body has covered 10 seconds, and on vertical axis there are actually graduations over here. Up to it can be different. Okay, speed is equal to distance by time. So how much distance is covered by the body on vertical axis, represented by del s, and how much distance the body has covered, not distance but time, how much time the body has taken, so represented by del t. So you can have the speed time graph. Okay, now there are different classes of speed time graph. The first is zero speed. Zero speed graph is very straight, parallel to the time axis or horizontal axis. Means the time is increasing, but the distance covered by the body is not increasing. So we say that the speed of the body is actually zero speed. And uniform speed, we get a very straight graph. The body is covering equal distances in equal interval of time. Okay, like this. In variable speed, the body is covering unequal distances in equal interval of time. So the graph is actually non-uniform graph. So the graph is like this. Look. Okay, now coming towards speed time graph. Do remember one thing, speed time graph is useful for two purposes. Number one, slope of a speed time graph always gives you what? Acceleration. This is one of the MCQs also. Okay. Let me draw the graph of it. For example, this is the horizontal axis, this is vertical axis. On horizontal axis we have taken time, on vertical axis we have taken speed. Okay, for example, a body is moving with uniform speed like this. So what we do, look, on horizontal axis we have time 0, 2, 3, 4. On vertical axis we have speed 2 meter per second, 4 meter per second, 6 meter per second, 8 meter per second, up to carries on. Okay, so we know that magnitude of acceleration is equal to change in velocity by time, and change in velocity can be given by final velocity minus initial velocity divided by time, final time minus initial time. Okay, if you see over here, initially the time was 0 and finally the time is 4, so we write 4 minus 0, and initially the speed was 0 meters per second, while final speed was 8 meters per second. So we write 8 minus 0, we get 8 by 4, and we get 2 meters per second square. So this is the value of acceleration. Okay. Now second thing, area under a speed time graph represents distance traveled. We will discuss two things, like a rectangular distance and a triangular distance. We are gonna discuss, right? Okay, the same, we are having horizontal axis, we are having the same vertical axis, the same, for example, 4 second time is taken by a body to cover a speed of to move with a speed of 8 meters per second. Okay. Now we are supposed to find out the area under this curve. We know that area formula is equal to length into width. Okay, or here say the length is del t and the width is del v. So instead of del t we write the same 4 minus 0, and instead of del v we write the same 8 minus 0. So we get 4 multiplied by 8, that is 32 meters per second square, which is the area value. Okay. Now similarly, if we have a graph for uniform speed, right? So we draw a graph like this, like horizontal axis time, vertical axis speed, the same we draw. Or here for triangular region, we know that the area formula is 1 by 2 base into perpendicular, or length into width, both we can say. Over here half is 1 by 2 as it is. Instead of length we will write del t, instead of width we will write del v. Okay, instead of del t we will write 4 minus 0. Similarly del v we will write 8 minus 0. Okay, we are going to get that 1 over 2 multiplied by 4 multiplied by 8. What we give us is 16 meters per second square area. Okay, now we are going to discuss the speed of graphical analysis of car's speed. For example, we are having a car, and the same horizontal axis we have drawn, we have taken time on that. On vertical axis we have taken speed. Okay. For example, the car is initially moving with increasing speed. Over here the graph, look to this graph. Over here in this graph we are having three regions. This is region number 1, this is region number 2, and this is region number 3. What is happening in these three regions? Look, in the first region the car's speed is actually increasing with the passage of time till 10 seconds, while up to 40 seconds the car's speed is uniform. Okay, and after next 10 seconds, like 40 seconds to 50 seconds, actually 10 seconds, so over here the speed of the car is actually decreasing. So we draw a graph like this. So this was graphical analysis of car's speed. Let me summarize today's work. Today's work was about graphical analysis of motion. We have discussed what is slope, we have discussed what is distance time graph, we have discussed what is speed time graph, we have discussed two of the cases in that, like area under the curve, as well as slope of a speed time graph gives you acceleration, we have discussed. And also we have discussed graphical analysis of car's speed, right? So this was all about today's lecture. Hope you have enjoyed the lecture. Thanks for watching. Allah Hafiz, fi amanillah.